So in this problem we have nitrogen plus hydrogen to make ammonia NH3, and we have 15 grams of nitrogen as a reactant, and we're wanting to know how many grams of hydrogen would we need in order to react with 15 grams of nitrogen. In order to make a comparison between these two reactants or between any two substances in an equation, we have to analyze it from a mole perspective. So that means we're going to have to go from our grams of nitrogen and convert that to moles of nitrogen. Once we've converted that to moles of nitrogen, we can convert that to moles of hydrogen, and we'll convert those between each other by using these coefficients out front, the mole ratios. And then once you have moles of hydrogen, it's an easy conversion to get to grams of hydrogen. Okay, so let's just jump right into it. We have 15 grams of nitrogen. To convert that to moles of nitrogen, we'll divide by its molar mass. Since it's diatomic, that's 28.02 grams of nitrogen in 1 mole of nitrogen. Next, we'll get rid of moles of nitrogen, and we're trying to convert 2 moles of hydrogen. And again, the mole-to-mole ratio right here is the same thing as their coefficients out front. So for every 1 in 2, you need 3 hydrogens. So hydrogen will actually be consumed 3 times as quickly as the nitrogen during this reaction. And then last, we need to get rid of that mole of hydrogen, and we'll do that by using its molar mass. The molar mass of hydrogen, which is diatomic, is 2.016 grams. And when we plug this in, multiply across the top, divide across the bottom, we find that we would need 3.24 grams of hydrogen. So what this means is 15 grams of nitrogen would need to react with 3.24 grams of hydrogen in order for both reactants to be used up. In other words, 15 grams of nitrogen needs to react with 3.24 grams of hydrogen. So let's go ahead and put that in here, this top part. 3.24 grams. And now let's get us some space. And what if I wanted to think about this another way? If 15 grams of nitrogen are going to use 3.24 grams of hydrogen, how much ammonia will that produce? Well, it's possible to do what we just did and go from grams of nitrogen to moles of nitrogen to moles of NH3 to grams of NH3, and I think I'd actually like to do that. So 15.0 grams of nitrogen, again divided by its molar mass of 28.02, now since we're going from mole of nitrogen to mole of NH3 this time, we need to use the coefficients of those two substances. For every 1 in 2, you are producing 2 NH3s, and 1 mole of NH3 has a molar mass of 17.034 grams. So we find that 15 grams of nitrogen would wind up producing 18.24 grams of NH3. Now, this actually makes sense given the law of conservation of mass. 15 grams of nitrogen went in, and additionally 3.24 grams of hydrogen went in, so the amount of mass that goes in has to equal the amount of mass that comes out. And since 15 plus 3.24 is 18.24, it is logical that 18.24 grams of NH3 would be produced. But in a situation like this, you're able to solve that problem either way. Let's look at this problem from a different perspective. This time, we have 10 grams of nitrogen, and I want to know how many liters of hydrogen do we need. Well, first we're going to make the assumption that this reaction is taking place at standard temperature and pressure, at STP, which is 0 degrees Celsius and 1 atmosphere of pressure. The reason for this is because at STP, 1 mole of any gas has a volume of 22.4 liters. So we can actually use that conversion to figure out 10 grams converted to liters of hydrogen. So we'll just start with what we know. We know we have 10.00 grams of nitrogen. So to get rid of grams of nitrogen, again, divide by its molar mass, 28.02. Grams of nitrogen is 1 mole of nitrogen. Again, the only way to switch between components of a reaction is to go through the mole. So we'll put mole of nitrogen on bottom, mole of hydrogen on top. For every 1 nitrogen, there are 3 hydrogens. And now in this next step, we're going to get rid of mole of hydrogen like normal, but since we're looking for a volume of hydrogen, we need liters up top instead of grams. And we know, since this is at STP, that 1 mole of hydrogen has a volume of 22.4 liters. So now we can just plug this into our calculator. And in this case, we'd find that it would produce 23.98 liters of hydrogen. Okay, so one more situation, still the same equation. This time we have 20 grams of nitrogen reacting with 6 grams of hydrogen to produce an unknown volume of NH3, or an unknown mass of NH3 rather. We want mass this time. We have to figure out which one of these reactants is going to run out first. And there are 2 ways you can do this. Why that's important is because once one of these reactants runs out, this chemical reaction has to stop. So for example, if I ran out of nitrogen first, once I run out of nitrogen, I cannot make any more NH3. The same would be true if I ran out of hydrogen. I would not be able to make any more NH3. Now you can't just assume that because there's less hydrogen that it gets used up before nitrogen does. Instead, we have to do some stoichiometry in order to determine which of these runs out first. And there are 2 ways you can go about doing this. The first option is to convert each one of the reactants to the product. By doing this, you're going to get 2 answers for the NH3, but since you know one of those answers will be smaller than the other, we can assume, we can safely bet that the lower of our answer is the actual answer. So let's just go ahead and start converting these. We have 20.0 grams of nitrogen. Again, its molar mass is 28.02 grams of nitrogen in 1 mole of nitrogen. 1 mole of nitrogen produces 2 moles of NH3. And 1 mole of NH3 has a mass of 17.034 grams. And we find that 20 grams of nitrogen could produce 24.32 grams of NH3. So what this means is if all 20 grams of this nitrogen were consumed, you would be able to produce 24.32 grams of NH3. Now, let's repeat the process with hydrogen. 6.00 grams of hydrogen, convert to moles, 2.016 grams of hydrogen is 1 mole of H2. There are 3 mole of H2 to produce 2 mole of NH3 according to our balanced chemical equation, and 1 mole of NH3 has a mass of 17.034 grams. And we find this time that the answer is 33.80 grams of NH3. So what this one in yellow means is if all 6 grams of hydrogen were consumed, you would have produced 33.8 grams of NH3. But up in the green, if all 20 grams of nitrogen were consumed, you would have only produced 24.32 grams of NH3. We have to go with the lesser answer here. This means that the maximum amount of NH3 we could produce is 24.32 grams because our nitrogen is our limiting reactant. Since this nitrogen could only produce this 24 grams, There's no way we could have produced a 25th or a 33rd gram down here because we ran out of nitrogen. So what we've just discovered is two things at one time. Nitrogen is our limiting reactant, and as a result of that, you can only produce 24.32 grams of NH3. So there is another way to work this problem. Sorry, I thought I had that pause. You said to watch me erase all that very slowly. It is possible to actually determine what is the limiting reactant by comparing the two reactants to one another. So if I will convert 20.0 grams of nitrogen into grams of hydrogen, so we're just going through this process that we've done several times already. For every 1 mole of N2, there are 3 moles of H2. And then 1 mole of H2 has a molar mass of 2.016 grams of H2. And we find our answer to be 4.32 grams of H2. Now we have to understand what this means. This means if you needed to use up 20 grams of nitrogen, you would need 4.32 grams of hydrogen. We have 6 grams of hydrogen. That is more than enough. It's more than 4.32, which means it's more than enough to react with the 20 grams of nitrogen. So that again proves to us that nitrogen is our limiting reactant. The reason I might have recommended doing this the other way, though, the previous way, is because we still haven't answered our ultimate question. The ultimate question here was to figure out what mass of NH3 we were going to produce. Now that we know nitrogen's our limiting reactant, you would have to go through your conversions again from nitrogen to NH3 in order to find the answer. Whereas if you had done this the previous way, you would simply pick the smaller answer, and that would have been your answer. But this has been a short introduction to some stoichiometry, including some limiting reactants.